All right, so we're going to do a high-level overview of what each of these material inputs means. Starting with base color. Base color is your diffuse or your albedo. You can see I've labeled it up here. Um, not too different than diffuse pipeline from before. I find this is where people tend to be the most confused with PBR. They say, how is my diffuse going to change? What am I doing differently here? The truth is not much. Marmoset has a great article on PBR. I highly suggest you look at it. It gives you a better, higher, level overview of what PBR is. But in their description of albedo, basically, it says, so traditional, diffuse is the lack of ambient light, ambient occlusion or directional light. Now, so this means, no ambient occlusion maps, no cavity maps being baked into your diffuse texture inside of Photoshop. The reason for this is that, if you think of a material being placed in a fully bright environment, it's not going to have a shadow. If you placed a 100% bright light, like a spotlight, onto a flat plane with your material, your maps on it, and there's ambient occlusion, that's not realistic. So Unreal, for example, does actually have an ambient occlusion slot at the bottom of the material editor here for you to plug just a simple black and white AO map into. And what it's going to do is it's going to multiply that over your diffuse when the object is not being directly lit. So any place where there's bounce lighting, ambient lighting, the ambient occlusion will be used there. And anytime there's a direct light hitting your mesh, it won't be used. And so that's the correct usage. If you're putting black values into a diffuse to simulate lighting that's not there, that's just not, it's not physically accurate. It's not how it would appear in the real world. So the biggest difference between a diffuse map, or as it should be called, albedo map, now and sort of the old workflow, is just no baked in lighting of any kind. After that, see metallic is the next slot. I'm going to open this map up here. So here we have an example of a metallic material and a non-metallic material. The other names for these are a conductor for metallic or a dielectric for the non-metallic. Now, a great example of this, I'll provide a link to the article that explains this as well. On the left, we have dielectric, or, non-metal materials, and on the right, we have conductors. So you can see, the base color of this, wood chess piece is brown, but the highlight is white. On this little block man, I can't remember what those are called right now. That's not Lego. His armor is blue, the reflection is white. We have a lighter blue shirt color here, the reflection is still white. Skin tone is, regular sort of pinkish, but the reflection is still white. Now on the conductors here, on these metallic objects, the metal itself has like a darker orangish brownish hue, and the reflection is a bright yellow. On this green Christmas ornament, the reflection is a light green. So you can see how essentially reflections change between metallic and non-metallic objects. Viewing this inside of Unreal, the best way to see that is to use a colored metal. So here we just have a plain chrome sort of metal. Can't really tell the difference. If I put gold on here, you'll see now the highlights are starting to be tinted. Whereas if I put a red plastic, it still has white highlights. Now, if I go back and put the metal and the non-metal next to each other, the only difference between these two is the fact that one is metallic and one is not, and that's being defined by the metallic value here in the editor. You really need to think of this like a computer would think of it, where, in programming, a value of 0 means false, whereas a value of 1 means, true. So if you think of a bool, a true or false operation in programming, what we're telling Unreal here is 1 means it's metallic, and 0 means it's not metallic. I try and think of this, to help make more sense of it as an artist. Think of it more like a yes or no question. Is the material metallic? If the answer is yes, is it a metal? You're going to use a value of 1. If, is the material metal? No, you'll use a value of 0. You don't want to use middle values because if you think, is this material metal, there's really only a yes or no answer. There is no sort of. There are no sort of in-between materials. There are a few exceptions. It's up for you as an artist to decide whether it's right or wrong to use a metallic value in those situations. I would say things like a water shader, things like that. You might want a metallic value because the color of the water is going to tint your highlight partially. But you might not want it to be a full value, so maybe 0.5. But typically, I would avoid it. I would only break the rule if you know exactly why you're breaking it. The old saying, you have to know the rules before you break them. So understand that the rule is typically you want 0 or 1. Now, specular, I've used it here to increase the specular highlight on the non-metallic material. On a metal material where metallic value is set to 1, specular does nothing. If you plug a map in here on a metallic material, it does absolutely nothing. Even on a regular material, it doesn't make that big of a difference. If I change this to 0.5, you can see the size of my highlight hasn't changed. It still is reflecting the environment. If I save this material here, you probably can't even really tell the difference with what happened on the right side. It's very subtle. If you don't have anything in the slot, it defaults to a value of 0.5. So the only reason to plug a value in here is if you want to change that. Now, if I put a value of 0, you'll see very obviously the highlight disappears completely. You will not ever want a value of 0. 0.5 is usually okay. I'm just setting it to 1 here to have my specular value be similar between the dielectric and the conductor material. So you might be asking, if you're coming from an older workflow, no specular, this is like crazy. How am I going to define my highlights? How am I, what do we do for that to come through? And that is where roughness comes in. Now, I think this is the most confusing thing about physically based rendering for people who are just learning it, but it's also the most important thing to understand, simply because physically based rendering, what's really defining your material is not so much your diffuse or metallic value, although they are important, but really your roughness value. So what you see here are a series of spheres going from a roughness value of 0 to a roughness value of 1. Now, while in the metallic shader, we said never use a middle value, only 0 or 1. Well, if I ask you, is that material rough? You can have more than a yes or no answer. You could say, sort of, it's partially rough, but it's still somewhat smooth. It's kind of glossy. And so because of that, you can have these middle values, because there is no just yes or no answer. And to be honest, a fully smooth material or a fully rough material don't really exist in nature. Now, we can exaggerate things a little bit for a game engine. If you look here, if you want a mirror-like material, you'll want a roughness of 0. Whereas if you want something that's really diffuse, where the light has scattered all over the object, then you may want a roughness value of 1. Typically, I would try and stay between 0.1 and 0.8 or 0.9 to be the most realistic. But yeah, you can really see here how this changes the look of your material. If I go back into the material test unit here, if I apply a glossy plastic, which you can see not as rough, you can see more of the reflection. Looks like what you would see at a ball pit at a McDonald's, if they still have those, versus a rougher plastic like a rubber. The reflection really tells you what type of material this is. When I look at this, I can see, oh, I know what this would feel like. This maybe kind of has like a greasier feel to it, while this maybe, it's like a little softer, while this would be a little harder. You could really kind of dent it with your fingers, while this, the rougher one might be a little more squishy. Whatever that brings to your mind in terms of looking at the value and what you think of how it would feel, you can really see how important roughness is to maintaining what type of material it is. If I change my roughness value here right now to, let's say, like a 0.3, now it's going between 0.3 and 0.6. I apply that here. Now we have a completely different type of plastic. Or if I raise this up even further, now we have something more in line with the blue plastic from before. So you can see, roughness is, I honestly think the most important input in this whole shader network. It's the one that really defines what your material is. So if you mess up your roughness value, it's obvious to anyone who looks at the material that it's not right. If I say, oh, this is a chrome here, but instead of my roughness value is between 0.5 and 1, someone's going to look at this and say, that's not chrome, that's like steel. That's a much rougher metal. So, now that we've kind of explored that a little bit, next value is emissive color. I'm not really going to go over that here. There's a lot of resources on emissive online. It's not pertinent to a PBR workflow. Emissive is essentially, as it sounds, the material has a light source in it. It is emitting light. So things like a monitor, if you have like a computer, a laptop model or something, the screen would be emissive. After that, we have normal map. Normal map has not changed at all. Your workflow, your pipeline for creating normal maps, exactly the same as it was before. Don't do anything differently. Just know that Unreal Engine 4, the Y is flipped. It's a Y minus normal map. So if your normal map looks incorrect, make sure you flip the Y value or the green channel inside of Photoshop. You can do that just by going into the Channels tab, selecting the green channel, and hitting Control-I. That will invert your green channel. You can save it out, re-import it into Unreal. So that covers the basics of what each of those inputs does. Base color, your diffuse, your albedo, metallic, whether the material is metal or not, roughness, how rough a material is, and then your normal map for, details such as scratches, lettering, whatever you need that sort of, to fake the appearance of height. Yeah, so those are the base values. In the next video, I'm going to go over some tips and tricks to get the most out of your textures, how to sort of think modularly with your textures, and how to bring them into Unreal, make sure that they're set up properly so that you're getting the correct values. So I'll see you in the next video.